Hello grade 12s. Today our focus is on interpreting and analyzing data. Statistics are very useful for presenting arguments. However, for the same reason, statistics is also open to misuse. Two people might use the same set of data to present opposing views for different reasons. Some would look at this glass and say that it's half empty. Some would say it's half full. So we need to be on the lookout for such misleading statistics in the media. Let's join Thandi and her friend Lebogang trying to challenge a certain company's arguments using statistics.
Yeah, but I hear you. But this is not even a big loan. She's been with you for 5 years. Now, I'm going to have to follow this up. I wouldn't be so sure if I was you, mister. I know my maths, and you'll be hearing from me soon. Could kill that guy.
Time out. Who are you trying to kill?
My cousin Lindy was boss. He's refusing to give them a loan to tide them over, and her husband's sick. But you know what? The company newsletter boasts about the fact that everybody there is fair and generous.
Maybe they are in other ways.
No. The average salary there is 6,000 rand a month, and I know for a fact that all 13 workers get 2,000 bucks.
But how can they say that then? It's a lie.
Well, not necessarily. It depends on how the average was calculated. Ugh.
This will calm you down.
Thanks.
What do you mean when you say how the average was calculated?
Look, if the foreman earns 25,000 rand a month and the boss 39,000 rand a month, then the average could very well be 6,000 rand. So they're not necessarily lying, but they're neglecting to mention how the salaries are distributed among the workers.
So the figures aren't reflecting the truth?
In a sense, no, but yeah, they are. Weird, huh?
Yeah. Well, I'm interested in all that, but duty calls. I'll see you later. Hey!
Hi.
I thought you could quickly show me some averages.
How come?
Sport, what do you think? Averages instead make sport far more interesting to watch.
Then you're going to have to listen carefully, because we're talking a bunch of data here, and how best to find a figure that can represent that data. But I'm not going to be using sports figures. I'm just going to concentrate on the salaries of my poor cousin and her colleagues.
Okay.
Right. There are 3 different ways of working out averages. First one, you have arithmetic mean, which is the average score. Then you have the median, which is a central most score. Then you have the mode, which is the most common score.
I'm sure you're going to explain all 3 in simple English.
Before Thandi explains more about the mean, the median, and the mode, we need to look at the data she is going to use. Her cousin works at a factory where there are 15 employees. The manager earns 39,000 rand, the foreman earns 25,000 rand, and the other 13 employees earn 2,000 rand a month. Thandi uses these figures to work out the arithmetic mean. She simply adds all the salaries together and divides by the number of employees.
Of course, man, come. As you can see, this one's easy. The 13 workers' salaries times the 2,000 rand that they earn, plus the 25,000 rand of the foreman, plus the 39,000 rand of the manager. And you divide that by 15 because there are 15 people in the company in total. When you add all that up, it gives you 90,000 rand, and you still divide by the 15, and it gives you 6,000 rand.
Yeah, so the arithmetic mean is obviously what the newsletter used. It kind of hides the truth a bit. But what would make it better?
Well, I'd say the mode or the median, the whole collection of data, and you put it from small to big. And the number that's in the middle would be taken as the average, but it's not used in everyday life.
Now, show me.
There are 15 items of data here. The 13 2,000 from the worker's salary, and 25,000 of the foreman, and the 39,000 from the manager. And this one here is a middle number. There's a 7 items on top and 7 at the bottom. Comprende?
See.
This 2,000 rand is the average salary, which is a far better reflection of what that company is paying.
This is quite interesting. So there is one kind of average left, and there is the mode.
Well, that one's also quite simple because you just look at the most common number, and the most common number here is obviously
2,000.
which is again a better reflection of what that company is paying.
It teaches me how to look at stats of the media quite differently.
So glad kids are learning about this at school already.
In math literacy, I presume.
What else?
So the mean, mode, and median can be used to present opposing views. Now let's join Jonathan, a maths literacy teacher, as he discusses how media may use statistics to mislead the public.
Jonathan Jacobs is teaching a lesson on mathematical literacy and the media at Macaulay House. He starts off by handing out different newspapers to the learners and asks them to look for articles or headlines related to maths literacy.
Oh guys, I found a percentage. Guys, I found a bar graph and a line graph. Guys, don't you think this would count as maths in the media?
I don't know, it just looks like numbers to me.
No, I think you've got to do a sum there somewhere.
It's clear that every newspaper is full of mathematics. Figures and graphs give an air of expertise and objectivity to a story that makes us trust what is being said. The big question is, can mathematics ever be used to slant a story? Jonathan demonstrates how survey results can be deceiving.
By way of example, which of you girls like tennis? Okay, 1, 2, 3.
Jonathan has predetermined who likes tennis in the class. He sends out a journalist to specifically interview the tennis fans on their favorite sport.
Well, trust me on this and go interview the girls.
What sports do you like?
Tennis.
What sports do you like?
Tennis.
Right. And you? Tennis, of course.
How many, out of all the girls that you interviewed, how many said they like tennis?
3 out of 3.
Okay, girls, now I want you girls all to imagine a massive headline in the newspaper saying, all girls interviewed at Macaulay House, 100% of them like tennis. So imagining that headline, what do you think, how do you feel about, and what do you think that headline would suggest about girls at Macaulay House?
Wouldn't that mean that all the girls who go to Macaulay like tennis?
Only a minority of the class like tennis, but a skewed interview can make it look like everyone does. When a percentage sign is used, people assume that a large sample of people were interviewed, that they were fairly chosen, and that they were not influenced by the interviewer. Jonathan hopes that by now the girls will be skeptical enough of the use of percentages to analyze this advertisement mathematically.
Since 85% of South African pediatricians and doctors surveyed feed their own little ones purity.
It only says 85% of pediatrics and doctors surveyed, so the other people who are not surveyed might prove it wrong. So it doesn't necessarily mean that it's true.
Probably found out that they only interviewed 5% of the pediatricians and doctors and not all of them.
Because it's only been 85 out of 100 doctors and pediatricians that were surveyed. So it means it's not really accurate.
How many do you think that they interviewed for this survey?
Probably the first 100.
850. But guys, this advert could be deceiving. Just because it says 85% of South African pediatricians doesn't necessarily mean that they interviewed all 1,000. They could have only maybe interviewed 20.
Excellent.
Jonathan asked the learners to calculate 85% of each of the sample groups. It turns out that the company could have interviewed only 20 pediatricians with 17 positive responses to come up with the slogan.
If they interviewed 1,000 doctors, then 85% is 850. If they interviewed 100 doctors, then 85% is 85 doctors. But if they only interviewed 20 doctors, then 85% is 17 doctors.
Now Jonathan shows another advertisement for a product, 100% body sensational. He asked the learners how they would measure body sensational.
Try to tell me how you're going to measure 100% of body sensation.
You can't measure body sensation.
But we've got the results here. 95% of women surveyed felt that their skin was smooth. 76% felt that their body looked slimmer.
How are we able to measure body sensation? Are we able to measure? Can they justify that?
I guess they can't, but then they just write it for us to believe the ad, I guess.
Percentages only have meaning if what they are measuring is quantifiable. Often companies use percentages to endorse products because people tend to take percentages seriously. Jonathan has prepared some graphs on the board to show how deceptive a graph can be, depending on how it is used in the media. He has made up a graph based on an issue that the learners can relate to, how average marks for mathematics have fluctuated at their school over the years.
Okay, girls, imagine you were a parent of a girl at Macaulay House. How would you feel about looking at this, about the math results in Macaulay House?
So I'd feel disappointed and take my child out.
Okay, girls, so from this graph, we can see that the results are going down.
Jonathan shows the girls the larger graph that the graph they saw was taken out of. Now they realize that they only saw a portion of the graph and that the bit they saw did not tell the whole truth.
Look at the graph that we drew previously, which was from 1997 to 1999, which shows that Macaulay's House results going down, was this period over here, from 1997 to 1999. Okay, it shows that Macaulay's House results are going down, but overall, at the big picture, we see that results are going up. Now, how would you feel as a parent having to look at the larger picture of the results at Macaulay House?
I'd tell other parents to bring their child to Macaulay House.
He draws another graph showing how maths marks have improved, but does not label the vertical axis.
But if you actually have a look here, what type of percentages would you think should be labelled over here?
85% at the top.
85% at the top, yeah? And over here?
20%.
Girls, in reality, the percentages over here are only 60 and 63.
We are going to look at 3 graphs that all show the same information. The first graph shows an increase of only 2 units over 12 months. Here is the same graph, but have a look at the axes. The y-axis starts at 600 here, not at 0. What effect does it have on the graph? Although it looks similar to the first graph, it looks as if the starting point of the graph must be close to 0. So it looks as if there is a gradual increase from a small number close to 0. The third graph here represents the same information, but it has been stretched. The y-axis uses smaller intervals between the units of measurement. Instead of increasing by 100 for each unit, it increases by 50 units. This graph shows the increase as a much steeper slope, and so we get the impression that the increase is much more than we thought. Now, if you were told that these 3 graphs represent the increase in the petrol price, which graph would worry you more? I'm sure you agree with me, the stretched graph looks more alarming. Even though the petrol price has been increasing too much for our pockets, this graph exaggerates the increase. The second graph is also unrealistic because at a glance, it looks like there is a very low petrol price and it rises very gradually. So, it is very important to be aware of the units on both axes of a graph, both when you are drawing graphs yourself and when you are interpreting graphs that you see in the media or in a maths literacy class.
The learners have started seeing how data and statistics can be used to manipulate people's opinions. From now on, they can look at data in the media more critically.
Lebogang, please get me 4 different colors of those.
Which ones? These?
Yeah.
1, 2, so.
Yeah.
Hey, man, I thought about your problem. You should write a letter to the paper. And I've got the headline. It says, Math Teacher Exposes Dodgy Maths.
And dodgy manager too. Hey, but do you think they'll print the letter?
Yeah, it's the responsibility of the media. They have to expose that, especially when it comes to statistics.
So what are the responsibilities of those who work in the media, and how does maths literacy fit in? We spoke to Ferial Hafaji, an editor at Mail and Guardian.
I think it's important for everybody to be math literate. In journalism, it's very, very important for me because these days so much is about budgets. Once you understand budgets, you understand economics and politics, and then you can be an effective watchdog over power, over political power, over business power. That's why for me it's quite important. Journalists, I think, don't often pick up the mathematical tricks or the percentage play that goes on in politics, and what that comes down to is the importance of training. So you'd think that with political reporters it's just okay to give people an understanding of the huge body politic. It's also important that people have maths and numeracy skills because that's core to understanding politics.
That was quite interesting. Let's make some notes on techniques media, advertisers and politicians will use to mislead people through the use of data. How to mislead people using data. Compare the mean, medium and mode of the data and use the one that best suits the message that you want to give. Leave out the titles and labels on the graph. Don't use a uniform scale on the graph. Leave some information out. Use 3-dimensional graphs to create a distorted image of the data. So remember to critically evaluate the graphs and statistics that you are presented with in future. Thank you for joining us, and remember to look at the tasks for this section in the Advanced Data Handling Tasks video. You'll also be able to learn more about data handling on our website www.mindset.co.za/learn. Goodbye.